자, 이번 시간에는 지난 시간에 이어서 Better Pricing 모델에 이어서 Mean Variance Frontier에 대해서 공부를 할 것입니다. 먼저 제일 기본적인 경우인 리스키 에셋이 두 개 있는 경우, 그리고 리스키 에셋은 하나, 리스크 프리 에셋이 하나 있는 경우부터 시작해서 나중에는 이제 일반적으로 리스키 에셋이 N개 있는 경우까지 갈 겁니다. 리스키 에셋이 N개가 있으면 수학적으로 조금 복잡하게 돼요. 그렇지만 차분히 따라가시면 큰 문제는 없을 겁니다. 자, 그러면 mean variance frontier에서 대해서 볼게요. mean variance frontier는 MVF라고 부르고요. 앞에 글자들 하나씩 따서. 자, MVF가 뭐냐? 모든 가능한 포트폴리오의 평균 수익률과 베리언스들의 집합이에요. 즉 무슨 말이냐면요. mean variance frontier는 2차원적인 그래프라고 볼 수 있는데 Y축에는 포트폴리오의 기대 수익률을 그리고요. X축에는 포트폴리오의 스탠다드 디비에이션을 그립니다. 자, mean variance frontier는 또 investment opportunity set이라고도 불려요. investment opportunity set은 뭘까요? 투자 기회의 집합이라고 볼 수 있죠. 무슨 말이냐면 여러분들이 이제 어떤 포트폴리오가 투자 가능한지 정할 때 그 포트폴리오들을 여기에 이 2차원 그래프에 전부 다 그려준 거를 investment opportunity set이라고 불러요. 투자 기회 집합. 따라서 여기에 있는 이 선에 있는 이 포트폴리오들이 여러분들이 선택할 수 있는 포트폴리오들입니다. So we will first look at very simple cases. 이 간단한 경우들이 어떤 경우냐면요. 먼저 two risky asset case. We will begin with the two risky asset case and also take a look at one risky and one risk-free asset, and we will combine them. And after that, we will look at a more general case of n risky assets. So let's take a first look at how two risky asset cases and one risky and one risk-free asset cases can be computed mathematically. 자, 먼저 제일 처음 볼게 이제 two risky asset case예요. Okay, so we will assume there are two assets, A and B, okay? And their expected returns and standard deviations are given as, so we will call it RA and RB overbar. Overbar represents expectation. And for standard deviations, we will use sigma A and sigma B. And another key parameter here is the correlation between the two. And we will see that correlation is a very important parameter that determines the shape of the investment opportunity curve. Okay. So given this, we will form portfolios using the following weights. So weight W, so weight is the portfolio weight in asset A. And because the portfolio weights should sum up to 1 minus W should be in asset B. Okay. Now we will form portfolios, okay? And the portfolio expected return is going to be the linear combination between A and B's expected return, okay? And we also need to calculate the standard deviation of the portfolio, but standard deviation is more complicated than variance, so we will just calculate the variance. The variance calculation is given in this way. So it's going to be W squared sigma A squared plus 1 minus W squared sigma B squared plus 2 times W and 1 minus W and the covariance between the two. Okay, and this covariance between A and B is simply correlation times each standard deviation. Okay? So where is this formula from? This is very similar to, so you can compare this with a simple perfect square. Okay? So it's as if you're expanding it, but instead you have instead of this, you have the covariance between A and B. Okay? So they're similar. Okay? Now, what do we want? We want is the investment opportunity set. Again, what is investment opportunity set? It's a two-dimensional graph of expected return on the y-axis and the standard deviation on the x-axis. Okay, so that is the investment opportunity set, and we have to calculate it. In other words, we want a relationship between expected return and the sigma. We want the relationship between the two. What are the two equations that we have? We have this equation and also this equation, right? And if you look at the two equations, expected return on RA and RB, so these are given parameters. So these are like constants. That is also constant. Also, the correlation is the constant. The only free parameter is W. So W is the free parameter. So W is a free parameter. So we need to get rid of it. Okay, how do we do that? From equation 1, okay, you can get an expression for W, which is expected return minus RB over RA minus RB. Okay, so that is the weight, and we need to plug this in. Plug this W. 이 W를 plug this W into the second equation here. Okay, then what will you get? It is a little complicated relationship, but it's doable. In other words, let me just rewrite it. Okay. Okay. So if you plug this W into this equation here, then you will get a relationship between, okay, what do you get the relationship between? Sigma and R. Okay. So let's take a look at some easy cases. Okay, suppose the correlation is 1. Okay, when correlation is 1, you get this following. Okay, so when correlation is 1, you get W times sigma A plus 1 minus W times sigma B squared, okay? So that sigma is a absolute value of W sigma A plus 1 minus W sigma B. And using this W expression here and the sigma expression here, what do you get? You get the following case. So when rho is 1, you get, and suppose asset A is here, asset B is here, then it's going to be a straight line that connects A and B. Okay? Now this line corresponds to the case where, this part here corresponds to a case where W is between 0 and 1. Okay? And when W is greater than 1, it corresponds to the case under A. And when W is less than 0, then it corresponds to the other case. Okay? And you can also do the calculation for when correlation is -1. Okay, and what do you get? You get an investment opportunity set like that. So similarly, if you want to go above these points, then W should be greater than 1, or W should be less than 1. Okay? And when W is, say, 0, and it's going to be a parabole like this. Okay, so this is hyperbole. In Korean, it means 쌍곡선. 쌍곡선이 됩니다. Okay. And the next important case is when there's one risky and one risk-free asset. So in this case, the portfolio expected return is W times A plus 1 minus W times risk-free asset, and portfolio variance is sigma squared of sigma A squared. Therefore, we get like that. Okay? And you can plot it, okay, given R and standard deviation. You will have, so the intercept is going to be the risk-free rate, and there's asset A. So this part is going to be a straight line, 직선이 되고요. 이 가운데 직선은, okay, when W is between 0 and 1, and when W is greater than 1, it goes above A, and when the W is less than 0, then it reflects in this fashion. Okay? So that is the basics of the investment opportunity set. So we looked at two cases. The first case in the previous slide is two risky asset case. Two risky asset case corresponds to the following three cases: when correlation is 1, -1, or neither. And the other case is when there's one risky asset and one risk-free asset. And in that case, investment opportunity set is just simply a straight line.